Some order is coming. Okay, where did we stop in the last class? Science convention for lens completed?
Yes.
Completed, right?
Yes.
And all the ray diagrams for lens also completed.
Yes, sir.
We have discussed uses of concave mirrors and convex mirrors.
No, we haven't covered uses.
Uses we did not, right? So let's quickly cover the uses of concave. So it is used in automobile headlights.
Sir, this
I know, but this we had missed.
Whereas,
We have completed
yes.
uses also.
Yes.
Okay, fine. The uses of concave lens and convex lens. Where do we use concave lens?
Sir, far-sightedness. Sorry, near-sightedness.
Far side. Ah, okay. Near-sightedness means yes, eye is able to see near object,
Yes.
but not far objects.
Yes.
Okay, so for far visibility, we use concave lens. So what is it called? It's called for correction of myopia. Used to correct myopia. So myopia is nearsightedness. Nearsightedness means you are able to see the near objects, not the far objects. Okay. So it is. We'll discuss it in more detail in the next chapter. Human eye. Used to correct. What else? Hmm? Is it given in the book? Uses is not given. Maybe it is given in the volume.
It is not.
It's not in the volume also?
Yeah.
So I think uses are only for mirrors only then, not for lenses. Okay. So one is this, for convex lens it is used in projectors. Just like this, it is used to correct
Hypermetropia.
hypermetropia, like farsightedness. Hypermetropia. This is called farsightedness. Okay. So I think this use part for lenses is not there. What you have is only uses for mirrors. Okay. And did we discuss power of lens? Only that is remaining. Power of lens and sign convention for power of lens. So what is power of lens? So power of lens is its ability to either converge or diverge. Okay. So it is the ability lens to converge or diverge coincidentally. So which lens has more power, thick or thin? So what's the difference between thick and thin lens? Which lens has more power? You are saying this is more powerful, right? So if its power is say P2 or is P1, you are saying P2 is greater than P1, right? So what's the difference between thin and thick lens in terms of focal length? Which has large focal length?
Thick. Yes.
Thick has large focal length. Why?
Because it's thick.
Because it's thick. So it has more curvature, right?
Yes.
So it has more curvature, so it will make a bigger sphere or a smaller sphere?
Bigger screen.
Are you sure?
No, that would be the smaller sphere.
Oh no, yes.
Now tell me, which focal length is bigger?
P1. P1.
Focal length is bigger? Okay. So this is C1 and this is, let's say, no, this will be C2, no? This is C2, right side. So if I call this as F1, the length F1, this is the length F2. Which is smaller? F2 is less than F1. Okay. So the lens with more power has small focal length, right? So there is an inverse relation. So power is defined as reciprocal of focal length. This is the definition. Now this is a converging lens. So which lens will bend more? This or this?
No.
Thin or thick?
Thick one.
Thick one will bend more because incident ray, parallel ray, this will be bent later, right? Okay, but here the bending is more. See the angle, this angle. Where the angle is more. Deviation is more in this case. But the focal length is short. So short focal length has more power. Has to be. If the f is small, p will be more. Small denominator results into more power. Correct? Got the funda? What did you smell this? Is it the adhesive? Okay. Everybody understood? Power is reciprocal of focal length. Right? Now let's discuss the unit of power. Unit is diopter. Unit of power is diopter and the symbol written is D. Okay. Now the unit is in diopter when F is expressed in meter. Meter. The unit of power is diopter when focal length is expressed in meter. So this is how you have to write. So this focal length unit is meter. Where? Is that clear? So always, whenever power questions are there, you have to convert focal length in meter. Only then you can write the unit of power as diopter. Diopter is D. Now let's discuss the sign convention. So since power depends on F, the sign of power will be sign of F. Right? So what is the sign convention? As per sign convention, what is the sign for convex lens?
Positive.
Positive. Okay, power of convex lens is positive, and for concave lens it should be
Negative.
Sign convention for positive for convex lens. Negative for concave lens. Okay, now let us do some questions. So with this we have completed your chapter. Right. Did we discuss the lens formula and magnification formula for lens?
Yes, sir. Yes.
We have discussed it. What is the difference between lens formula and mirror formula? What is lens formula?
Minus 1 by U.
1 upon f equals 1 by b minus
And
1 by b.
magnification. So magnification formula for lens. So what is it? 1 by f is equal to 1 by b
Minus 1.
minus 1 by u. And n is equal to
b
b by
upon
u.
u.
b upon u. Okay? And this remains same. H dash by h. Okay? So b by u. Here the sign is changed. Okay, if you have any questions, you can ask. Otherwise, we'll go after the variables. Any question? Anyone? No? Let's solve the variables. So, come to page number 60 of your volume. Page number 60.
Sir,
Yes.
when A part with the optical center, why doesn't it go to any deviation?
So, okay. So basically for that you have to understand the structure. Right? So what is a lens line? Actually, if you look at the middle part of the lens, okay, if you divide the lens like this, it is like consisting of so many prisms. Okay, it's like prism, right? But if you look at the middle part of the lens, and these lenses are thin lenses, right? So this part is like a rectangular glass slab. And when the part is like a rectangular glass slab, right? So whenever the light is entering at a rectangular glass slab, are you going to get any deviation? You get deviation, or you get lateral shift. I said it's a thin lens. It's a thin lens. It's a thin lens. So any light ray, if it is passing, is there any deviation? Make it thin. It will be almost straight. If you reduce the thickness, the lateral shift will also reduce. So it's that. Okay. The upper and lower portion, had I told you, had I described how it is taking place? Did I tell you, like, let's say this is the ray. I told you that this ray is reaching at the middle of the lens, right? And then we show it is converging.
I didn't get the refractive index.
Refractive index.
Yes, like absolute refractive index of a medium.
But that was the beginning. I mean, before lens, we had covered that.
Yes.
So you have a doubt.
Yes,
Okay. Which one? Absolute refractive index.
yes.
I'll come to it. Let me first explain how this reflection takes place. So basically, so you have two center of curvatures, right? One on the left and one on the right. Okay, so this is the point of incidence at the first surface. So what is the normal at this point? Because for refraction you require normal. What is the normal here? Normal will be this. This is normal, right? Radius. Now this is a denser medium. When the light is entering at this surface, so it is a denser medium. So it will bend towards the normal. Correct? And now this is the another point of incidence on the second surface. So what is the normal for this? Correct. The radius of curvature for the second surface. So it should bend away or towards? Away, because now you have a rarer medium. That's how it comes from here. There is bending at every surface. Got it? Likewise here, this is a rectangular glass layer, right? This is a rectangular glass. So if you had the object here, and if it comes here, what happens? Then again you have a normal here. It will bend a little bit. Okay, so if the thickness is less, the bending will be very little. Okay, so it will almost pass through the center. This is how it is. You get the idea? So, but then we don't show it like, I mean, you don't show the bending at two places. But this much of details is not expected actually. Everybody understood what's the funda? That's why if it is passing through the optical center, it is assumed straight because the middle part is taken as rectangular glass layer. Okay. Now coming back to absolute refractive index. Refractive index you have understood?
Yes.
Okay. So what is refractive index?
So basically, refractive index is when is the measure when a light passes through a medium, like light.
Different mediums.
Yes.
So it is the measure of how the speed changes in different mediums. So it's basically ratio of speed of light in incident medium versus its speed in the refracting second medium.
Yes.
Okay, and we write it like n21. Okay, so this is n21. How do we read it? Ri of refractive index of second medium with respect to first medium. This is how we read it. Let's say the first medium was water and the second medium was glass. Then what it will be? Speed of light in water versus speed of light in glass. Correct?
Yes.
Now, what is absolute refractive index? If say the first medium was air, okay, so I can write refractive index of glass with respect to air will be what? Speed of light in
Speed of
light in
light
air.
in air upon speed of light in glass.
Let's say speed of light in glass is v. In this situation, we don't write the first medium. We just write ng.
Oh.
So this is absolute refractive index of glass. So whenever refractive index of any substance is given, it is always with respect to air. And it is always absolute refractive index.
Okay.
So now we don't say it is refractive index of glass with respect to air. What do we say? We say it is refractive index of glass.
Glass.
So it is absolute refractive index of glass. So when incident medium is air, okay. So then Ri of the medium is its absolute refractive index.
Yes, sir.
And the first medium is not specified.
Then it's.
Then it is understood. It has to be
It
air.
has to be, yes.
Good. If you are coming back with questions, that means you're trying to revise and understand. So this is what I want. So if you don't have doubts, means you're not studying. And you'll study at the time of exam, then the struggle will be very high. Is this clear?
Yes.
Okay. Can I erase all this? Anybody has doubt here? This is how the actual refraction takes place. But in all the ray diagram, right? What have we done? Having understood the nature, okay? Now we have simplified it. We just come till the middle of the lens. We don't show the refraction here and refraction here separately. And we know if it is parallel, it has to pass through focus. Okay? And if it is going through optical center, then it won't deviate. As simple as that. Okay? These details are not expected, so don't worry about it.
So why does no deviation take place when the ray passes through the principal in the mirror?
Huh?
Why does no deviation take place when the ray passes through the mirror?
Means optical center. वही तो बताया ना? That's what. इसका क्वेश्चन वही था ना?
मिरर का पूछ रहा हूँ, उसका लेंस पूछ रहा
अच्छा, मिरर में क्या क्या है? Why? हाँ बोलो. What is the question?
हूँ। मिरर के प्रिंसिपल एक्सिस से जब रे पास करता है तो डेविएशन
Deviation कैसे होगा राजा? यहाँ पे तो रिफ्लेक्शन है ना? I mean, frame your question correctly. मतलब क्या पूछना क्या चाह रहे हो?
Like the ray passes straight to the pole.
Ray incident on the pole.
Yeah.
That's it. What is your question? Ray incident on the pole. Rays incident on the pole here or here along the principal axis.
On the pole.
On the pole like this, oblique. Then क्या question क्या है फिर? Question क्या है? Question क्या है? एक मिनट इधर आओ, इधर देखो. ये रिफ्लेक्टिंग सरफेस है ना? This is point of incidence. तो point of incidence में क्या लगेगा? Law of reflection. Law of reflection क्या बोलता है? हमको चाहिए नॉर्मल. प्रिंसिपल एक्सिस में तो नॉर्मल है कि नहीं? From C, anything that is going from C to P is a radius. ये देखो C से कुछ भी लेके जाओ इधर, रेडियस है. Radius is always normal, correct? तो अभी ये अगर प्रिंसिपल पोल पे इंसिडेंट हुआ, so this becomes angle of incidence. सुन रहे क्या? This becomes angle of incidence. तो अब इसमें खाली रिफ्लेक्टेड रे बनेगा सेम एंगल का बिलो द प्रिंसिपल एक्सिस. डेविएशन नहीं होगा इसमें. इसमें क्या होगा? रिफ्लेक्शन होगा. रिफ्लेक्शन देखो शुरू में रिफ्लेक्शन रिफ्रैक्शन थोड़ा कंफ्यूज हो गए तुम लोग. Once you become accustomed with mirror, इसलिए पहले सारे मिरर के क्वेश्चन सॉल्व करो, become comfortable with it, फिर लेंस पे आओ, ठीक है? तो थोड़ा जंबल अप हो सकता है, ठीक है, दैट्स नॉर्मल। लेकिन एक ही चीज याद रखना है कि पॉइंट ऑफ इंसिडेंस पे लॉ क्या लगेगा? लॉ ऑफ रिफ्लेक्शन। इस केस में क्या, कौन सा लॉ लगेगा? स्नेल्स लॉ। समझ में आया? दोनों लॉ लगेंगे अलग अलग, ठीक है? मीडियम चेंज हो रहा है, यहाँ पे ट्रांसपेरेंट मीडियम है, यहाँ पे रिफ्लेक्टिंग मीडियम, ये फर्क है, ठीक है? Shall we proceed? Okay. Any more questions?
So I have
हाँ बोलो।
so I can understand
हाँ?
so I can understand convex
Convex lens. Like what? What about convex lens?
like nature of
हाँ. Okay, nature of image not understood. So now the doubts coming. Like, what is convex lens? You want to know?
yes
Okay.
concave and convex both.
Okay. So what about it? How the ray diagram is forming in this? So I just explained how the convergence is taking place. Huh? So you have to understand that if the ray is parallel, then it will pass through focus. This is the law. Use it as a law. It will pass through focus. Any ray which is parallel to the principal axis has to pass through focus. Okay? And any ray which passes through optical center will go undeviated. This we have given before the ray diagrams. Which ray to select for making the image. Right? Now for image formation we require only two rays. So I have selected these two rays. Most diagrams has only these two rays. Except the first one. In the first diagram, we are selecting two parallel rays because our object is at infinity. So whenever the object is at infinity, only parallel rays can come. For example, when you look at star, what is the example of object at infinity? Star in the night. It appears to you like a dot. So if two rays are coming from the star, still they will appear coming straight to you. Okay? So any object when it is at a infinitely far away distance, the two rays will be parallel. Okay? तो उस केस में हम एक रे प्रिंसिपल एक्सिस के ऊपर लेते हैं और दूसरा रे कहाँ से लेते हैं? नीचे से। तो उस केस में अगर कोई पैरेलल रे नीचे से आ रही है तो वो कहाँ जाएगी? वो भी इधर जाएगी। समझ आया? ये तो नेचर होगा कि रेज कैसे पास होते हैं आफ्टर कॉन्वेक्स लेंस। और इमेज फॉर्मेशन कैसे होता है? Whenever two rays intersect physically, वहाँ पे रियल और इन्वर्टेड इमेज बनता है, ठीक है? And if the rays after refraction or reflection, ठीक है? इस केस में क्या होगा? For same ray, अगर same parallel ray हम यहाँ से लेंगे, now what happens? इस केस में opposite होता है, diverging lens में। क्या होता है diverging lens में? ऑपोजिट मतलब ये फोकस की तरफ गई थी, इधर देखो पहले समझो, ये फोकस की तरफ गई थी, ठीक है? ये फोकस से अवे जाएगा, ये वाले फोकस, ये भी तो फोकस है, दो फोकस होते हैं ना लेंस में, लेंस में दो फोकस होते हैं, क्यों? क्योंकि दो कर्व सरफेस होते हैं और हर कर्व सरफेस का क्या होगा? एक सेंटर होगा, सेंटर होगा तो उसका मिड पॉइंट भी होगा, दोनों साइड दो सेंटर होंगे। ये समझ में आया ना लेंस कैसे बनता है? दो स्फेरिकल ग्लास, सॉलिड ग्लास स्फीयर से बनेगा, तो उसका एक सेंटर इधर, एक सेंटर इधर, फिर O से सेंटर का मिड पॉइंट यहाँ पे, O से सेंटर का मिड पॉइंट यहाँ पे, दो फोकस भी हो गए, ठीक है? अब मैंने क्या बोला? पैरेलल रे या तो फोकस पे जाएगी कॉन्वेक्स लेंस के केस में, क्योंकि ये कन्वर्जिंग लेंस है, डाइवर्जिंग में ये फोकस से अवे जाएगी यहाँ से, ठीक है? और वैसे ही अगर नीचे से तुमने कुछ लिया तो ये क्या होगा? ये भी फोकस से अवे जाएगा, ये वाले फोकस। अब इसमें कैसे इमेज बनेगी? रेज डाइवर्ज हो रहा है, ठीक है? Whenever rays are diverging, that time what you are supposed to do? You have to extend it backwards. In this situation, the image is called virtual image. यानी property क्या होता है virtual image का? Can it be obtained on screen? No. इसको screen पे नहीं, जैसे mirror में तुम अपने आप को देखते हो, that image is virtual image. Image में जो तुम्हारी mirror है, वो virtual image है. Mirror के पीछे किसी को भेज दो, तो तुम दिखोगे क्या उसको? नहीं दिखोगे. वहाँ पे कुछ screen रखोगे, तो उस पे image नहीं आएगी. That's why it is called virtual image. लेकिन ये दिखती है, ठीक है? इस केस में क्या होगा? If you place a screen, okay, you can see the image. समझ आया? तो ये हो गया तुम्हारा कौन सा टाइप का इमेज? रियल इमेज. क्या होता है रियल इमेज में? टू रेज फिजिकली इंटरसेक्ट. लेकिन when the rays after refraction diverge, तो इमेज क्या बनती है? बैकवर्ड एक्सटेंड करके जहाँ पे it appears that these rays are coming from here. मतलब उसको लगता है वो ऑब्जेक्ट यहाँ पे है, जहाँ से वो रेज आ रही है, वही इमेज. समझ आया? तो ये कौन सा इमेज बना? वर्चुअल. और रियल इमेज की प्रॉपर्टी क्या होती है? हमेशा इन्वर्टेड होता है. ठीक है? तो डिफरेंट ऑब्जेक्ट पोजीशंस के लिए तुम्हारा रेस ये रूल के हिसाब से मिल गए. बट बेसिक सी समझ आया? तो अभी देखना बाकी के रे डायग्राम्स प्रैक्टिस करो और पढ़ के फिर. और ऐसे पढ़ो मत. यू ड्रॉ द एक्चुअल रे डायग्राम विद ऑब्जेक्ट प्लेसमेंट, तो दिमाग में जाएगा. यू कैन नॉट रीड रे डायग्राम्स, यू हैव टू ड्रॉ इट टू गेट द सेंस ऑफ इट. मतलब F सेंटर में आता है, 2F2 या 2F1 के सेंटर में आता है. ठीक है? वो सब करके देखना पड़ेगा. Any more questions, anybody? Okay,
Snell's law मतलब उतने अच्छे से नहीं समझा.
ये एक एक्सपेरिमेंटल ऑब्जर्वेशन है, स्नेल्स लॉ. ठीक है? तो स्नेल्स लॉ क्या होता है? देखो, तुम्हारे पास अगर कोई रिफ्रैक्टिंग मीडियम है, आई एम श्योर ये बहुत लोगों का क्वेश्चन होगा, स्नेल्स लॉ. ठीक है? तो स्नेल्स लॉ क्या है? ये एक रिफ्रैक्टिंग सरफेस है, ये भी इट इज रिफ्रैक्टिंग सरफेस, राइट? तो स्नेल्स लॉ लगाने के लिए उस पॉइंट पे फर्स्ट टू ड्रॉ द नॉर्मल, देन टेक एनी ऑब्लिक रे. ठीक है? तो ये क्या हो गया? एंगल ऑफ इंसिडेंस हो गया. Then you can observe, make an observation. वो हमने देखा था ना रेक्टेंगुलर ग्लास लैब में, इंसिडेंस और एंगल ऑफ रिफ्रैक्शन बन सकता है. ये कैसे आएगा? तुम यहाँ से रे ले लो, दो पॉइंट को ज्वाइन करो, तुम्हें मिल जाएगा आई और आर. यू कैन एक्चुअली एक्सपेरिमेंटली वेरीफाई दिस. ठीक है? नाउ यू हैव प्रोटेक्टर. You can measure angle I and measure angle R. Now find sine of I and sine of R. ये पता है ट्रिग्नोमेट्रिक रेशियोज, व्हाट इज साइन I and साइन R? पता है? तो यू फाइंड साइन ऑफ दैट एंगल जो तुमने मेजर किया अभी एंड साइन ऑफ एंगल R, उसका रेशियो निकालो. समझो तुमको कुछ मिला x. ठीक है? फिर ये जो पिन जो तुमने डाले थे ना, अलग अलग डालो, आई चेंज करो, तो ऑब्जर्वेशन टेबल बनाओ. ठीक है? you'll measure I, you'll measure R for various observation. ठीक है? एक्सपेरिमेंट में तुमने अलग अलग एंगल ऑफ इंसिडेंस के लिए I और R नोट किया, फिर तुमने सबका I और साइन ऑफ I और साइन ऑफ R निकाला. Now you are finding in the last table sin I divided by sin R. Mathematically, you will find that all these values are constant. Same idea. For a given pair of rectangular, pair of media.
Yes.
And this light has to be monochromatic, single color light. सबको समझ में आया? तो ये एक्सपेरिमेंटली हम ऑब्टेन करते हैं किसी भी एक सब्सटेंस के लिए। तो फॉर अ गिवन पेयर ऑफ मीडियम एयर ग्लास है ना, कलर ऑफ लाइट, ये रेशियो तुम्हारा कांस्टेंट ही आएगा चाहे कोई भी एंगल पे तुम लाइट इंसिडेंट करो। बात समझ में आई? इसलिए तो उसको कांस्टेंट बोलते हैं। कांस्टेंट बोलेंगे क्यों? ये एक्सपेरिमेंटली ऑब्जर्व्ड फैक्ट है। So physics is experimental science. We observe nature and then we derive laws. ठीक है? And on the basis of that, then we make predictions. Because this happened yesterday, it should also happen tomorrow. That basis. That is science. And a systematic study of natural phenomena. Then we draw the observations and then make laws. यही है scientific study. तो तुम बड़ी क्लास में जाओगे तो ये थोड़ा और इसके बारे में सीखोगे। Why we are studying what we are studying, but right now you are fed like A for apple, B for baby, without applying too much mind, है ना? You can't ask why A, why this is called A. Can you ask this? Why we are not calling this as A? Because since childhood we have trained you like that. कि जहाँ पे भी ये diagram दिखेगा उसको A बोलना है। This is like framing laws. ठीक है? But nature has already things taking place. So now we are trying to draw laws from nature. Means why it is happening all the time like this. So now this is studying nature. That's what is science. Systematic study of natural phenomena. Okay. Any more doubts? The team is on fire today, huh? So don't ask doubt for the sake of it. Huh? Study, have doubts, and then ask doubt. That will be more meaningful. Okay? All right, let's do some questions. Is it clear? I guess now refractive index part is now clear what it means. And questions will come to only those who is trying to understand. So that's a good thing. If questions are not coming, that's not a good sign. Questions will come only to those who are trying to understand. ये भी है. Okay, come to page number 60 and look at example 9.3. So what is given? You have a concave lens. Concave lens. Concave lens has focal length of 15 centimeter. What will be sign of it?
Negative.
Negative. Okay. It is negative. At what distance should the object from the lens be placed? So you are basically supposed to find what is the object distance so that it forms an image at 10 centimeter from the lens. Ten centimeter. Now what kind of lens is this? Concave. What is the nature of image formed by concave lens?
Virtual.
Always virtual. Correct? Now, what side the image will be there? Where is virtual image? Left side. So will it be positive or negative?
Negative.
Positive. Negative. It is given concave lens. Only one type of image formation takes place in concave lens. Only virtual. Got it? So that's why the funda has to be stored. Right? And see the sign convention. Image formation by convex lenses. Okay, so it's not given. The sign you have to judge by the name of the lens. Okay? So for concave, only virtual image forms, no real image. Alright. Then you have also find the magnification produced by the lens. So you have to also find magnification. So do it. So you have 1 by, now you have to use, okay, another common mistake. By doing lot of mirror formulas, even for lens you apply mirror formula. So be very clear. That's why you write concave lens, concave mirror. So when you start doing questions together, so far we had only written just concave or convex. Okay. So make a habit of writing concave lens, right, when it is given. Okay. So then you apply the mirror formula or lens formula accordingly. Okay. So this is the lens formula. So what is U then? Therefore 1 by U is equal to 1 by V minus 1 by F. So this is minus 10 minus 15. So it is 1 by 50 minus 1 by F. So what is the LCM?
30.
30. So this is 2.
Minus 2.
This will be minus 1 by half. This is minus 1 by 3. So this gives us U is equal to minus 30. So it had to be, U has to have minus sign.
Now, sir, does magnification have the unit?
No, because it is same object, the same dimension by same dimension, length by length, ratio of similar quantities, right? So now V is M is equal to V by U for lengths. So what is V? It is minus 10 and U is minus 30, we just found. So 1 upon 3, M is 1 by 3.
0.33.
Ah. So this could be 0.33, whatever. So magnification is this. Okay. So what is the image size? Is it diminished?
Diminished.
Enlarged?
Oh no, diminished. Sorry.
So S dash by H is equal to 1 by 3. In concave lens, it is never enlarged. Virtual image is enlarged only in convex lens.
Convex lenses.
This is another result. So if you know this, then you can actually predict your answer whether it is correct or not correct. Okay. So this is what it is. Okay. And since the magnification is positive, anyway it is. All right. So anybody has any difficulty understanding this question? All clear?
Yes, sir.
Huh? Take a minute to think whether it is clear to you or not. Have you understood all steps? In question, it is not asking what is the nature. We knew the nature, that's how we wrote this minus sign. Okay? So they are not asking about the nature. Right? Shall we do the next question? If you want, you can write a note over here. B is negative sign because concave lens always forms virtual image. Okay, so which is on the same side as object. Right. So this was which example? 9.3. Now let's do example 9.4. So what is given is a 2 centimeter tall object. So given object length as 2 centimeter. Placed perpendicular to the principal axis of convex lens. Also given as convex lens of focal length 10 centimeter. So convex lens, focal length has to be positive only. Find the nature, position and size of image. So you find V, nature of image, and you have to find the size of image. These three things you have to find. And also magnification. And M equal to. You have to find M also.
We have object.
We have object U is also given, right?
Is given.
U given is how much? 15 cm.
So it will be minus 15.
Minus
That becomes minus. Okay. So in the numerical, the sign will not be given. Okay. So you have to carefully apply the sign. Okay. Solution. So what is V? 1 by V will be equal to 1 by F plus 1 by U, right? Okay. So this will be 1 by 10 and U is minus. This also 30. V minus. V is 30. Is this correct? V is 30 centimeter. So V is positive, so image has to be real and inverted. Positive way means image on the other side. So it has to be, in case of lens, it is real and inverted.
Here it will be enlarged.
So that we'll find after we calculate the magnification. So what is M? So M is equal to V by U. 40 by minus 20. So this is minus 2. So negative sign of M means real and inverted. So negative M means real and inverted. And M is greater than 2. Magnitude is greater than 2. So it is twice. Now look at what is H dash. This means H dash is equal to minus 2 times H. Okay, how much is H? 2 centimeters. So it is minus 2 into 2, minus 4 centimeters. H dash is image size. So image size minus, so it is below principal axis. Okay, got it? So it is inverted. H dash sign is negative, so it is inverted. So everything we have given, real, inverted, this is magnified or enlarged. All details are decoded. Okay. So that's about it.
So in this, there are so many questions.
Right. So there are classwork review questions on page 73. So 1, 2, 3, 4, I think you can do. We've covered in theory. Question number 5. What kind of lens is used by watchmakers? Concave. They should magnify the image or magnifying glass, right? Huh? That is concave. Concave lens, image is diminished.
Convex.
See the image is diminished. Okay, so virtual, right? Convex lenses. Which image position will use? 6th. How do we place? Like we keep the lens very close. Fine arts, very fine. If there is a medicine printed, name printed very fine, so use a magnifying glass. So we keep the glass very close to the object. So that is 6th image position. So that image now gets enlarged and it is virtually erect. Virtual and erect. So
Forms are real and what?
always,
Not always.
I said 6th one. Okay. So what kind of lens is used by watchmakers? Convex lens. Why? Because it produces a virtual and enlarged image. It produces virtual and enlarged image. How do the frequency and wavelength change when light passes from an optically rarer to an optically denser medium? Yes? Read question 6. Okay. No. That question 6. What kind of lenses produces both real and virtual image?
Convex.
Only convex. Okay? Because concave produces only virtual image. Question 7. How do the frequency and wavelength change when the light passes from an optically rarer to an optically denser medium? So V is equal to nu lambda, right? You know this formula. So what is nu? Frequency.
So that is for sound.
For any wave. For any wave velocity, this formula is applicable. Okay. So for C also velocity of light, right? So whenever refraction takes place, so during refraction, frequency remains constant. Okay? So if frequency remains constant, because it depends on the source. Therefore then V will directly depend on wavelength or wavelength is equal to V1 nu. And this becomes, so wavelength will depend on V. Okay? So what will happen? In the second medium, the speed will slow down if it is denser. Then wavelength will also increase or decrease. Okay? So wavelength will decrease in the denser medium. So what is the question?
The frequency and wavelength change when light passes from optically rarer to optically denser.
So write down no change in the frequency. No change in the frequency because frequency depends on the source. Write down. What are you thinking? I mean, more explanation required. Source means source of light. What is source of light? this bulb. Okay. Let's say in lab, the source of light could be a sodium lamp. So that produces only yellow light. So there are different sources of light. Okay. So the source has its own frequency because it is emitting light at a particular frequency. Got it? So frequency is the property of the source. Okay. So that does not change when it passes from one medium to other medium. But wavelength will, because now the speed is slowed down. So speed depends on wavelength. So the product 1 by nu into V will give you wavelength. And since V is reducing, the wavelength also will reduce. Okay. So you have to write the answer. No change in frequency, but wavelength reduces due to reduction of speed of light in the denser medium. So we'll discuss more questions in the next class.
Physics and